Okay, friends, what we've come up with so far is pretty exciting, actually. It's a future value formula. It's a future value formula. However, remember, I'm glad I'm seeing this green up here, we got to make sure we multiply the future value formula by the amount that continually gets deposited each year. In our case, it's $500. I will tell you that in general, very often what they'll do is they'll call that something else like a variable like A for the constant deposit. I mean, I don't know. It depends on, you have to kind of tease out the meaning of the variables when you actually look at formulas. We just got to make sure we take care of that when we do our future value. So our future value, I'm going to go back to FV with periods. This is not F times V, it's just future value shorthand, is going to be. So R, in our case, is 1.06. It's going to be 1.06 to the t plus 1, whatever those values are, minus 1, all over. Now check this out. R minus 1. R is 1.06. Minus 1 would just be 0.06. 0.06. And then multiply all of that times 500. All of that gets multiplied by 500. If we stick that value in to a calculator with a given value of t, we will see then the value future of any one of our years into the future, 5, 10, 15, 20 years. So what I'm going to do now is I'm going to, let's see if I can get, I'm going to go to my favorite online calculator. If I can get this to hold still without killing myself. Okay. Let me get her all queued up here for us. Zoom back a little bit, maybe. Ooh, back. Oh, that's as far back as it's going to go. I could really use some kind of production stand. Blank screen, Firefox. Why is that big old weird bar up there on the screen? I don't know why. I'm going to use something called Wolfram Alpha. Now, if you've never used Wolfram Alpha before, this will be a wonderful introduction for us. Yes, we can see it pretty well. Even though that big annoying bar is up top there on the screen, we can still see this okay. So when you go to Wolfram Alpha, it allows you to put any expression into its little, it looks like a search bar, and it really is. But you can also use it as a really, really effective calculator. So watch this, watch this. I'll give you a simple example first. What is 1 plus 3? You press enter and it tells you that it is 4. The result is 4. Yay, yay, very good. Okay. Let's do our problem with it. What would the expression value be if we put 500 bucks in for 20 straight years, including the initial deposit of 500 in the beginning? So by our little formula, that means we got to go 1.06 to the 21st power. Remember, 21st power. 21st power minus 1. All, I'm going to check my parentheses here. You notice that a parentheses out here. Okay? All divided by 0.06. Remember that. 0.06 in the bottom. And then I got to multiply all of that by 500 bucks. I know it says 21. Remember, it's the 20th year. We have to input the 21st value because of that awesome thing Dr. Peter Monk showed us. You ready for this? Give it a couple seconds to compute. It comes up with, it says $19,996.36. Let's just see, for grins, let's go in here. Projects, annuities. Should give me a warning because it's open in my office, and that's okay. Read only. Pop-Pop's annuity, hey, $19,996.36. It matched it beautifully. It matched it beautifully. Looks the exact same expression. It's out to crazy numbers of decimal places, but it matched it beautifully. And what's so cool about this is, you might ask yourself, what happens after 30 years? What happens after 30 years? And after 30 years, it's going to come back with $42,400. Another question you might ask is, okay, so we know it makes $19,000, almost exactly $20,000 after 20 years.
what if Pom Pop was able to put in $600 a year instead of $500? What would that amount grow to? It would be $4,000 more over the course of those 20 years. $4,000 more. What if it was $1,000 he put in every year instead of $500? He'd be almost $40,000. You double the amount, roughly double the amount that comes out. So what's so cool about this is once you have the expression, you can tool around with it. Now that doesn't mean you can't tool around with a spreadsheet. I love spreadsheets. But the thing about a spreadsheet is, especially the way it's created here, you would actually have to go through and create these previous ones to go further. And again, it's just a matter of copying and pasting. But at the same time, those of you interested in the math behind it will hopefully grow to love Wolfram Alpha. Wolfram Alpha is pretty awesome. It does more than just calculations like that. It'll also, it's called an information engine or a computational knowledge engine. That's how they sell themselves, computational. So I'll just give you an example. Our son's name is Max. If I type the word Max in, let's see what it comes back with. Max, male given name. Currently, U.S. births, he's the 118th most popular name in America. One in roughly 550 people have that name. About 3,400 people a year are named that. Here's the graph of the popularity of Max's name. Oh, that's actually kind of cool. Let's see, where are we right here? He was born in '07, which means we named him right before the popularity spike, it looks like. So there's 2005, right in the middle there. We named him right before it got cool to name your kid Max. I'm a trendsetter, what can I say? Anyway, you've got a really, really cool tool here with Wolfram Alpha. This is why I don't make students use TI graphic calculators anymore. They're dead. It's a dead technology. This internet-based stuff is the future. But if you watch these past couple videos, you also have an appreciation for algebra and its applications. And that's kind of where I think the sweet spot is algebra with technology. Anyway, I'll stop babbling. Hope this helped. See you in class.